Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is differentiation of trigonometric functions. In this video, we are going to discuss how to find the derivatives of the very basic trigonometric functions sine, cos and tan. We will be using first principles to find the trigonometric derivatives. I'll give you the first principles for sine and cos. In order to do the calculations, these are the two first principles that we will be using in the calculations in finding the derivation of trigonometric functions, which is necessary. Here is where you can understand the necessity of radian measure. Okay, that h in the denominator be measured in radians. Now h is a change in x, so x must also be in radians. Okay, we will see how to apply these two first principles in derivation. First, let's find the derivatives of sine and cosine functions, sin x and cos x, where the angles x is in radians. Okay, we are going to prove that if f of x is sin x, then f dash of x is equal to cos x. So first we can see the graph of both sin x and cos x. Graph is just for your reference. Now let's do the proof part. Let's find what is f dash of x. That is, we are going to prove f dash of x is equal to cos x. So here let's use the formula. F dash of x is limit h tends to 0 f of x plus h minus f of x over h. Hope you all are familiar with this formula. This is the formula we apply when we are supposed to find f dash of x with a function f of x. Okay. So our next step is just replace f of x by sin x and f of x plus h by sin h plus x. Okay, in this equation, just replace f of x by the given function and f of x plus h by, I'm just replacing x by x plus h in the same function. Hope you're clear with the step. Now we need to expand this one. So for this one, we can use sin a plus b formula. Sin a plus b is sin a cos b plus cos a sin b. So let's apply this and expand this particular one. After expanding, we can see there are three terms here. We can just group the like terms and take the common factor outside and write the leftovers within the parentheses. Here we can see sin x cos h and sin x. So I can see two common factor here. So I can take common factor outside and write the leftovers within the parentheses. Sin x outside, cos h minus 1. So I'll get, hope you're clear with the step. Okay. We have two terms in the numerator. I'm just taking this limit for both the term and separating. H is the common denominator for both the terms, so I'm just writing it separately. So I can apply the first principles. Are you clear with the step? Hope you remember the first principles. Limit h tends to 0, cos h minus 1 over h is 0. Am I right? And limit h tends to 0, sin h over h is 1. So by applying the first principles, we will get, I'll quote the principles here. Let me give you the steps elaborately. I'm taking this limit h tends to 0 before this expression so that you can understand that we are going to apply the first principles here. Okay. Since we know that the first principle, cos h minus 1 over h is 0 and sin h over h is equal to 1. By plugging in these two principles here, we will get sin x times 0 plus cos x times 1. 0 times anything is 0 and 1 times any term is the term itself. So this term gets vanished out and this would be cos x. So if the function f of x is sin x, f dash of x is cos x. So this is the proof for the first formula. Hope you're clear with this one. Okay, similarly, we can also try for cos x. Before that, I'll give you an alternate way to derive this derivative. First, let's start with f dash of x, the same expansion, same formula. Now let's use the trigonometric formula sin a minus sin b directly. Okay, before that we used sin a plus b formula, but here we are just going to use sin a minus sin b. Let's start with replacing the function f of x by sin x and f of x plus h by sin x plus h. Now you can just apply the formula sin a minus sin b. I'll give you the formula too. Sin a minus sin b is 2 cos a plus b over 2 times sin a minus b over 2. Here with a as x plus h and b as x. I'll just mention that too on the board. Hope you're clear so far. We are just going to apply this formula and get the answer directly. So apply this formula here. We will get 2 cos in the place of ax plus h and in the place of b ex. Same here. Please be careful with the negative sign here. And the denominator is same. Hope you're clear with the step. Okay, here did you notice that x plus x is 2x and x minus x gets cancelled out here. So after simplification, we will get limit h tends to 0, 2 cos 2x plus h over 2 sine h over 2 over h. Hope you're clear till this step. You can just rewrite this as the common thing. 2 and 2 gets cancelled out, and you can write the common denominator separately for each of the term in the numerator. X plus h over 2. We need to apply the first principle here. That's the reason I'm just rewriting everything. And I'm going to use something here, and to rewrite this I'm getting cos x plus 2 cos a plus b is nothing but cos a plus b. Does this make sense to you? Okay, here is where we can apply the first principle. In first principle, we saw that sine h over h is equal to 1. I mean, sine, the same thing in the denominator will give you 1. So here we are having sine h over 2 over h over 2, which is nothing but, you can take the limit here. So this will give you 1, and you will be left over with, if h tends to 0, 0 over 2, so cos x will remain, and this will turn into 1. Cos x times 1 is cos x. That's it. Hope you're clear with both the direct method and the alternate method. In both the methods, we will be using the first principles. Okay, now let us take one example and see how to find the first derivative. I mean, how to differentiate the trigonometric function sine. So here is the example. Here is an example. F of x is sine 5x. We are supposed to find f dash of x. As usual, let's use the formula. F dash of x is limit h tends to 0, f of x plus h minus f of x in the numerator divided by h in the denominator. In this example, function f of x is sine 5x and function x, f of x plus h is sine 5. Replace x by x plus h. So we will get, as the proof, we are going to use sine a plus b formula here. Same as the proof, we are going to apply sine a plus b formula. Sine 5x cos 5h plus cos 5x plus times sine 5h. Okay, so let's expand this. Now check for the common term and just group it according to the common term. And we are going to rewrite this denominator. This denominator is common for each and every term in the numerator. We are just going to split it. So we will get, now just take the limit within this so you can apply the first principle. Take the limit. The terms here are different. We cannot apply the first principle. So we are going to do one simple calculation. Multiply each term by 1 in the form 5 over 5. Okay, so that we will get, multiplying dividing by 5 will not make any change. Am I right? Because we are doing the same operation and opposite one, multiplying and dividing. So this just gets cancelled out. That is nothing but equal to 1. Okay, so we will get sine 5x 5 limit h tends to 0 cos 5h minus 1 over 5h. The terms are same. Cos 5x times 5 limit h tends to 0 sine 5h over 5h. The terms are same now. 5h sine 5h over 5h cos 5h minus 1 over 5h. So here is the place we can apply the first principle. Always cos term tends to 0 and this sine term is equal to 1. So 5 times 1 is 5 and 0 times this entire term will get vanished because 0 times anything is 0 itself. So 0 plus cos 5x times 5. Until you get enough practice, it is better to quote the formulas, the principles, rules that you're using. But it is not necessary that you have to mention that in your examination, just for your reference purpose. Okay, so I'm just going to quote the first principle that we are applying in this step here. So finally, 0 plus 5 cos 5x. So our final answer is, that's it for this example. You can also try the same problem using the alternate method, the second method, using the direct formula sin A minus sin B. You will get the same answer at the end. We will be also discussing the derivative of sine, cos. Already we have discussed sine. We will be discussing cos, tan. Those are the basic one. And we will also discuss the derivatives of tangent. I mean tan, cotangent, secant and cosecant. from those of the sine and cos function. Sine and cos functions are the basics. We will be using that again and again because tan is nothing but sine over cos. And cotangent, secant and cosecant are the other trigonometric terms which we derive from the basic sine and cos. Okay. And one more thing, cotangent function will be derived indirectly. We will also discuss that in our future videos. And I always recommend to memorize the derivatives of 6 trigonometric function. Hope you got an idea on differentiating the first trigonometric function, sine. In case if you have any query regarding this, kindly let me know. In our next video, we will be starting with differentiating the second trigonometric function, cos. In case if we have time, we can continue with tan, or we can make few more videos. We will be dividing the videos into parts. This is the part 1 video. In case if you have any